Question 8. Two observers, Abu and Badu, 46 meters apart, observe a bird on a vertical pole from the same side of the bird. So they are on the same side. The angle of elevation of the bird from Abu's and Badu's eyes are 40 and 48 degrees respectively. If at the foot of the pole, Abu and Badu are on the same horizontal, illustrate the information in the diagram for A. B. Calculate correct to one decimal place the height of the pole. The first question is to illustrate the information in the diagram. Going back to the question to illustrate the information in the diagram, that's this question in the diagram. Two observers, Abu and Badu, make Abu A and Badu B, 46 meters apart. Observe a bird on a vertical pole on the same side of the bird. So let's say these are vertical pole. They are the same side of the bird, so we have them on the same side. We have a straight line. You know, their angle of elevation, the angle at which they look up, since they're on the same side, you can just draw a slanty line and another slanty line. Now, you know, when you're dealing with questions like this, you know, this is in 90 degrees. To know which one comes first, this is where the twist in the question lies. One is 40 and one is 48. Now, students might not know which one comes first. And if you're very good with angle of elevation and you have something like this, you know the one with the larger angle comes first, which is Badu. The question says Abu is 40 and Badu is 48 degrees. So we know Abu for A and Badu for B. Represent them with A and B. But in your exam, you can write Abu rather than write A and Badu rather than write B. So we know that the one with the 48 degrees comes first. So we have this angle to be 48 degrees. The closer you are to the vertical pole, the bigger the angle. So it's going up and it gets to 90 here. So as you are going closer until it gets to 90 here. So this one is 48, which is Badu, which is B. And Abu, which is behind, is 40 degrees. So we have this other angle as 40 for Abu, which is A. We can write it Abu and Badu. We can write it in full, so you don't get it mixed up or you don't get it wrong. So this is Abu. Abu is 40 degrees and Badu is 48 degrees. Now going back to the upper part of the question, it says the two observers, Abu and Badu, are 46 meters apart. So we know between Abu and Badu, this distance is 46 m. And we can say this is the pole. We can indicate the pole, that's the vertical pole. Observe a bird on a vertical pole. This is vertical pole. From the same side of the bird, we have both of them on the same side, you can see, and they are 46 meters apart. The angle of elevation of the bird from Abu's eye is 40, so we have it as 40 here. From Badu's eye is 48 degrees, and like said earlier, the closer you get to the pole, the larger the angle, so the angle is increasing. Once you know this, you can easily solve questions like this. That's where the twist lies, and if you get it all mixed up, you get your answer wrong. Or you might get marks for method, showing that math doesn't just mark you out because your answer is wrong. It sees into your method, your understanding of the topic, and you can get marks for that. But for better understanding, you should understand this technique. This is where the twist lies, and once you've undone the twist at this point, you're ready to go. If at the foot of the pole, Abu and Badu are on the same horizontal, we have them on the same horizontal as a straight line, and this is illustrating it in the diagram. This answers our first question. It was while the initial video meant for question 8b was being edited that we discovered that there might be another way of solving this question, and this way seems easier than the initial method. Therefore, we had to make this video so you can actually choose the method you prefer or have an understanding of both methods. In a case that you're in a question that the first method doesn't work, you can apply the second method, thereby making you better experienced in math. This second video had to be done and will be made the first method to solve question 8b. There are actually at least 3 methods of solving this question. This method and the other one are quite similar. They have the same style of solving the question, where you have to use sine rule to find a line, either this line or this line, then use it to find the height of the pole. The initial method had to do with using only Pythagoras theorem that led to a simultaneous equation, which students might find difficult. Therefore, the second method was created to give you another insight to how you can solve this question. And this is also opening your eyes to the fact that there are some questions that you have more than a way of solving. At the end of watching this video, you would be able to pick which method you prefer. It is best to watch the video containing both methods so you'll be better equipped for questions that might come in any form. We therefore jump on it. We have 8b, calculate correct to one decimal place the height of the pole. That means we're calculating the height of this. This is the pole. Here we're going to be using sine rule and Pythagoras theorem to solve this question. This method was discovered while being inquisitive about finding all the angles. Now let's say we have, for example, this is our straight line. Now let's say we are interested in finding all the angles that can be found under law. We know this is 48, this is a straight line. If this is a straight line and this angle is 48, that means the rest will be 180 minus 48. That's this angle will be 180 minus 48 to get this angle. And once we have this angle and we have this 40, this is the peak of the pole where the bed is. We can put it at P, and this is the base of the pole. Now let's say we consider this triangle that goes from Abu to Badu to the top of the pole. This triangle. Now that we've found this and we know this is 40, we can find the third angle, which could be found using sum of angles in a triangle is 180. Once we have this and we have this side, we can find this side and use this big triangle to solve for the height of the pole, considering the bigger right angle triangle. There are actually 3 triangles here. Most likely you have come across a puzzle where you have a particular shape and there are lines in it, and they will ask you how many triangles can you find in this shape. If you know, there's a big triangle 1, this small triangle 2, and this triangle 3. We have 2 right angle triangles, the bigger one, the smaller one, then this third triangle here. Now we'll go on and solve. The reason why this method of solving this question is put first is because it seems seemingly easier than the second one. And with this being said, you can watch the video that has the 2 methods, then you choose. It's only right you watch the video of the 2 methods, because there might be certain situation or question where you would only be able to solve the question using one of the 2 methods. So it's just best you watch them and know them and add them to your experience. Now let's go on to solve. We're looking for this angle here. Let's call it angle B. So it's B to A, Abu, that's Badu to Abu to the top of the pole, this angle. So we know it's, let's call it B. So we know B plus 48 equals 180 degrees. That's angle on a straight line. Now we have it B equals 180 minus 48. The plus 48 crosses the equals to sign and turns to minus 48. So we have it as B equals 180 minus 48 will give you 132 degrees. That means this angle B is 132 degrees. We can erase the B and put 132. Now we have this as 40 and this as 132 degrees. We can now find this angle here. Now to find this angle, we have to put into consideration this triangle, Abu, Badu, and the top of the pole, like this triangle. And with that, we'll solve for this angle. Let's name this angle angle A. So we have it as big A. We know 40 plus 132 plus A should equal 180. That's sum of angles in a triangle. That's this triangle here. So we have it as 40 plus 132 plus A equals 180. In brackets, sum of angles in a triangle. Now we had 40 plus 132. It gives us 172 plus A equals 180. A equals 180. You know, this is plus 172. Once there's no sign written or it's hidden, it's definitely positive. So you have plus 172 crosses the equals to sign and turns to minus 172. A equals 180 minus 172 will give you 8. That means angle A is 8 degrees. So we have this as 40, this as 132 degrees, and this as 8 degrees. Note that this is not a right angle triangle, therefore Pythagoras theorem will not work. Now this is where we either apply sine rule or cosine rule. Students are often confused when it comes to which to apply, whether it's sine rule or cosine rule. But once you're sure you found all possible angles you can find or the possible side you can find, try sine rule first. If sine rule doesn't work, then you can try cosine rule. In this case, sine rule will work. We are looking for this long side, and this long side will help us find the height of the pole. The reason why we need this side is because if you consider this big triangle, once we have this side, which is the hypotenuse, because it's facing 90, when you consider the big right angle triangle, that is also the hypotenuse, and we have the angle which is 40 here, we can find this side, which is the height of the pole, using Pythagoras theorem. So we therefore need this hypotenuse, this side first. The second method that can also be used to solve this question, which is similar to this one we're using, is also using either sine or cosine rule to find this line, Badu to the pole. The line of Badu to the pole, this line here, once you have it, is also the hypotenuse of the smaller right angle triangle, which is from Badu to the base of the pole to the top of the pole where you have the bird. So we have it as this. Once you find this line, with this 48, using Pythagoras theorem, you can find the height of the pole. So it's that straight. Finding the height of the pole can either be done with using this hypotenuse or using this hypotenuse. Since this question has been solved before and sine rule will solve it, let's withdraw so we can understand what we're doing better. For us to better understand how to solve this question, we've actually taken this part of the triangle off from the major diagram. So here we have this angle as A, and you know when you're using sine rule or cosine rule, if this is big A, this is small a, and we're looking for this side here, that we can make it this one big B and this one small b. So the angle carries the capital letter while the line carries the small letter. And using sine rule, which says A over sine A equals B over sine B. We don't need to introduce C over sine C. Now we know our small a is 46 meters, our big A is 8 degrees, that's the angle. Then our big B, which is the angle, is 132 degrees, and our small b, which is the line, is unknown, which we're looking for. So we use that in solving. We have it as A is 46 over sine A, it is 8 degrees, equals B over sine big B, which is sine 132. 46 over sine 8 is 0.1392 equals B over sine 132, with our calculator will give you 0.7431. At this point we cross multiply. We have it as B times 0.1392 equals, on the other side, 46. Now take this 46 times 0.7431. B times 0.1392 equals 46 times 0.731 will give you 34.18. Since we're looking for B, we divide both sides by the number multiplying B, which is a decimal. So we divide both sides by 0.1392. This cancels this. You left to B equals 34.18 divided by 0.1392 will give you 245.5 meters. That means this line B is 245.5 meters. We can write it here in the bigger diagram. So we have 245.5 meters. Now we know this is 245.5 meters. We can now solve for the height of the pole, taking into consideration the big right angle triangle. Now we have this side and we have this angle 40, ignoring the inner line and all the angles inside. And taking the right angle triangle, we can use an angle a side to find any other side. So we use that to solve the question. And for the sake of better understanding, the diagram will be redrawn so you can understand what is being said clearly. Redrawing the diagram, we have it as now. Having this, we can actually solve for the height of the pole, which is this. So we have 40 degrees. We've taken away the line inside and all the angles inside. So we have this shape. We can solve for the height of the pole using Pythagoras theorem, where you have to indicate which side is which. So we have this as our opposite. The one facing the angle we have, which is angle 40, this is the opposite. The line facing the angle 90 is the hypotenuse, and the last one is the adjacent. And we've been asked to find the opposite side, which is this. And we have the hypotenuse and we have an angle. The Pythagoras theorem that has both the opposite and the hypotenuse is sine theta. We have it as sine theta is opposite over hypotenuse. So we say sine 40 equals our opposite is the pole, which is unknown. We can make it P over our hypotenuse, which is 245.5 meters. We can say this is over 1, then we cross multiply. So we have P times 1, which is P, equals 245.5 times sine 40 degrees. Now P is equal to 245.5 times sine 40 is 0.6428. The height of the pole P is approximately 157.8 meters, which is our final answer. A quick summary of this approach to solving this question is that with this 48 degrees, and this is a straight line, we can find this angle. This is 180 minus 48, and it will give us 132 degrees. This is 132 degrees, and this is 40 degrees, and this is a triangle. We can find this angle, that 180 minus the addition of these two. Sum of angles in a triangle is 180. So if two of them are this, then the third one will be the addition of the 2 minus 180, which will give us this as 8 degrees. So we have this as 8 degrees. Now with this 8 degrees and this side, we can find this side, or we can also find this side. That's another method that is similar to the one we're using sine rule. And with sine rule, we discovered that this side is actually 245.5 meters. Now we're done with using this angle and this angle, and we don't really need this angle to find the height of the pole, because we now have to use this big right angle triangle to find the height of the pole. Taking into consideration, we have an angle which is 40 degrees of a big right angle triangle and a side which is the hypotenuse, which is 245.5 meters. And with that, using Pythagoras theorem and knowing that this side, which is the height of the pole, is the opposite side, which is facing the angle we have, which is angle 40. Now this and this side that we have, which is the hypotenuse, it is facing the 90 degrees. We then find the height of the pole using sine theta is equals to opposite over hypotenuse, and with that we get the value for the height of the pole to be 157.8 meters. 8b, calculate correct to one decimal place the height of the pole. When you look at the question like this, particularly from the topic we got this question from, and looking at the question, you know the question is from angle of elevation and depression. What should come into mind is solving using Pythagoras theorem, because you're seeing an angle 90. That means you should be looking for anything related to right angle triangle. And in this case, if you look closely, we have two right angle triangles. We have the first one, the bigger one, at 40, you have it like this, then the smaller one, which is this. But in other cases, you might have to use some other theorems that are related to triangles. You might have to use cosine rule, sine rule, or any other thing that is related, provided you're seeing a triangle. Now, for you to solve with Pythagoras theorem, we can change this pole to y, and distance from here to here, that's from Badu to the pole, as x. Taking this as a small right angle triangle and this as a bigger triangle. So we have two right angle triangles. This one we can name it 1, and this one, which is 2. Now we're having two unknowns. That's like we're having Pythagoras theorem with a simultaneous equation. So we'll solve. Most of us would have solved questions similar to this, and we'll still explain for a better understanding of this. Since we have two unknowns, the only solution is to create two equations like simultaneous equation. So we start with this. For the smaller right angle triangle that has Badu to the pole, this is the base of our pole P. This is our angle, and this line facing the angle is the opposite. We know this is our right angle, and the line facing it is the hypotenuse. So this is our hypotenuse, and the last part will be the adjacent. We're using the adjacent and the opposite, although both are unknown, to create our first equation. So we have it as opposite and adjacent, and the only of the Pythagoras theorem that has the opposite and the adjacent together is tan theta. So we have it as tan theta equals opposite over adjacent. That means tan 48 degrees equals, our opposite is y and our adjacent is x. This is our first equation, which is derived from the smaller right angle. This is 48 degrees, this is y, and this is x. For the bigger right angle, which is from Abu to the foot of the pole, then the top of the pole where you have your bed, you have it like this. That means you have 46 plus x as the distance between Abu and the base of the pole. Take a look at it. This is 46 plus x. We can't use this other triangle because it's not a right angle triangle. It's not going to help us solve. So we'll take this as for the big triangle with our angle 40, then this, and our y still remains our y. So for the second equation, let us draw another diagram for better explanation. So we'll have it as this. We'll have our 40 here. The distance from Abu to the pole is 46 plus x. That's the total distance. You travel 46 here and x here, so it's the addition of the two. If this were 46 and this were 2, this will be 46 plus 2. That's this total distance is 48. We still have the height of our pole to be y. So we have this as y. And we know this is our right angle triangle. Next, we find all the sides. This is 40 degrees. The line facing it is the opposite. That's opposite to the line. Then this line facing the angle 90 is the hypotenuse. We don't need it. Then the last one is the adjacent. We have our adjacent and our opposite given to us in algebraic form, and the relationship between the adjacent and the opposite is tan theta. So we have tan theta again equals opposite over adjacent. That means tan 40 degrees equals, our opposite is y and our adjacent is 46 plus x. That's our equation 2. We can now rewrite equation 1 and 2, then solve for y, since it says find the height of the pole. The height of the pole is y. If you solve for x first, you waste time, then you now have to solve for y. You are asked to find y, so you can eliminate x by making x subject of formula, then you find your y. So let's rewrite equation 1 and 2. Now we have our equation 1 and we have our equation 2. We can just start solving or simplify to make it simpler for us to eliminate x. We'll make x subject of formula, then we'll eliminate it. So we have for equation 1, we have tan 48 equals y over x. You can say tan 48 over 1. Then we'll cross multiply. We have it as x times tan 48 equals y. Now, since we want x to be subject of formula so we can eliminate it, we divide both sides by tan 48. So we have x alone. Tan 48 cancels tan 48. X equals y over tan 48. And y over tan 48 is 1.1106. So from equation 1, we know x equals y over 1.1106. Then for equation 2 is tan 40 equals y over 46 plus x. Here too, we're trying to make x subject of formula. So we cross multiply, you can see this is over 1. Then we cross multiply, we have y times 1, that's y, equals 46 plus x in bracket times tan 40. Be careful here, because the tan 40 doesn't only affect the 46, it affects the x too. Both of them are linked by addition, even if they are linked by subtraction. And when you are cross multiplying, whatever is on this side affects the two of them, so you should be careful with that. Then you have y equals 46 plus x in bracket, then tan 40 is, with your calculator, is 0.8391. At this point, you can open the bracket, you multiply 0.8391 by 46 times x. So we have it as y equals 46 times 0.8391 will give you 38.5986 with your calculator. Then you have it times x, it will give you 0.8391x. Now, since we want to make x subject of formula, we'll move this one out first. It's like solving normal algebra, but here we have our x in decimal. Well, it's still the same process, don't let it scare you. That's one of the twists or technicality in this year. So you take out this 38.5986, so you have it as y minus 38.5986 equals 0.8391x. Since we're looking for x, we divide both sides by the coefficient of x, and in this case is 0.8391. So we divide it by 0.8391, 0.8391, both sides. This cancels this. So we have our x, since we're having x left on this side, you can write it now on this side, equals y minus 38.5986 over 0.8391. Now from our equation 2, we've made x the subject of formula. We made x to stand alone, same as we did to equation 1, which is this. We can then equate both values to one another. We can bring out our first equation, which is x equals y over 1.1106. This is one we derived with equation 1 by making x subject of formula, and this is one we derived with equation 2 by making x subject of formula. We can now equate the value for both x's to themselves, because it's still the same thing either way. That's what it means. So we can take it as y over 1.1106 equals y minus 38.5986 over 0.8391. Don't be afraid of the decimals, you just cross multiply like usual math. So you have 1.1106 times y minus 38.5986. This 1.106 affects the y and the 38.5986. So it's 1.1106 into open bracket y minus 38.5986. On one side, you close the bracket, equals, on the other side, you have y times 0.8391. So which is 0.8391y. It's like 2 times y is 2y. So not minding the decimal, is still going to be with the y. Next, we open the bracket. 1.1106 times y is 1.1106y. It's like 2 times y is 2y. Then 1.1106 times minus 38.5986. Put the minus first, then multiply these two decimals. You get approximately 42.87 equals 0.8391y. Now, just like working with normal algebraic expressions or algebraic questions, the one with the y's, you put them on one side, collect like terms, then we take the constants out. Since we don't want a negative y, and this 1.106y is greater than this, so we'll bring this in and take this minus 42 out, because like I always said, this 42.87 owns the negative sign in front of it, so we'll take it out. So we have 1.1106y. We'll take this plus 0.8391y inside, it turns to minus 0.8391y equals 42.87. Don't be afraid of this decimal, like I've always said. It's just like having 2y minus 1y or 3y minus 1y. Like 3y minus 1y, you just say 2y. You take out the y, then subtract the numbers. You subtract the numbers. 3 minus 1, that's 2. Then write one of the y. Same applies to this. You just write the y, then use your calculator to do 1.1106 minus 0.8391, which gives you 0.2715 y equals 42.87. Since we're looking for our y, we divide both sides by 0.2715. This cancels this. Y is equals to 42.87 divided by 0.2715 will give you 157.9006. And going back to the question, remember the question says your answer should be in one decimal place. So we have it as y equals 157.9, because this is not up to 5. Everything behind goes away. You consider the number behind, which is 0. If it were 5, you add 1 to this. Then since it's going to be 10, this will be 8. We don't have that complexity. So we take out all the numbers and leave the 9 as 9. And our answer will be y equals 157.9 meters. Remember to put your m.